all changes in x, so x plus h, remember this? That was like the pre-calculus stuff. We're now entered derivatives. I taught you the general rule. Does anyone remember the general rule? If y equals
fx.
If y equals x to the n, the derivative is
nx, to the power of n minus 1. But shouldn't it be y equals ax to the power of n equal to
Yeah, it should be
nax?
well, that's the extension of the general rule.
That's the full rule, sir. Show full.
The original rule was fine. You've just added a coefficient, which is good. Okay, so that's the general rule. I'm actually going to use the one that I first said without the a. Okay, so you bring the power out the front and you minus 1 away from the power. So this is all about rates of change. I'm going to show you now a new rule. So if you had a function, it had more than one term. I don't know if you remember terms in algebra. So you have x squared 3x. What would you do with the separate terms to find the derivative? You apply the rule to each term individually. What's in between each term? The symbol plus. Okay, if there is a multiply, this is where the product rule, hence the word product, comes in. Okay, so if you have two things being multiplied and you want to find the derivative of the whole thing, you use this rule that we're learning today. Makes sense, boys up the back that are giggling? Up the front that are giggling?
Yeah, it's great.
Can you please take it out of your ear and actually pay attention? So, there's a couple of ways that the rule is expressed. So, the first way, it could be expressed in terms of a function is equal to a function times a function. You see that? The derivative of that h function is, so the first function times the derivative of the second function plus the derivative of the first function times the original second function. Okay? So there's 4 steps to do this. The first step is to just make, so the whole function, you split it up into 2 functions that are being multiplied, yeah? So you assign one of them as u, one of them as v. You then find the derivative of both of those and then shove it into, or sub it into the equation. Okay? I'll show you what I mean. Let's find the derivative of this one. So what could be the u? The u could be this bit, and the v could be the quadratic. Very good. Okay, so first step, make a function u and the other function v. Yep, because I want to find the derivative of y. Everyone with me so far? Okay, now what was the second step? Anyone remember? Find the derivative of both of those I call them sub-functions because they're a function within a function. It's like inception. Okay, so what's the derivative of u? No. The constant becomes 0 and the x becomes 1 because x to the power of 1 becomes x to the power of 0, which is 1. Because we're minusing 1 from the power, yeah? Okay, the next one, what's the derivative of that one? Remember the... Yep, I can hear some of you said 2x plus 3, so we're just using the general rule. minusing the power away, bringing the power, the original power out the front. Yep. Okay, so now that I've found the derivative of u and v, what was the third step? Anyone remember? Put it into the formula. So dy dx equals u, yep, dv plus v du. Okay? Alright, so dy dx is x plus 2 times 2x plus 3 plus the v is x squared plus 3x minus 5 times by 1. Okay? So can you see how much simpler that could be instead of expanding a whole bracket? Does everyone see? Yeah, dramatic. I'm throwing down the bottle for dramatic effect.
Touchdown.
I'm hoping you kind of see how much easier that is than. Okay, so that's our final product of the product rule. Okay? Yay! It's not meant to be too difficult. You just remember first function times the derivative of the second, second function times the derivative of the first, or the sub-functions. Okay?